go with 9.5. Okay, so we're kind of switching gears today, moving away from your special right triangles. Okay, so in our special right triangles, we were able to solve for certain side lengths because we had the x radical 2, the x radical 3, and the 2x, right? We were able to solve that way. Well, what if you have a triangle that it's still a right triangle, but now what if that was 42 and that was 48? What's your general equation? How are you going to solve for a side? Besides Pythagorean theorem, if you were given two sides. Do we have any idea how to solve that? No, we don't. On the board, you guys have been asking, what is SOHCAHTOA? What is that word? Well, that's how we solve this now. We use trigonometry. That's where SOHCAHTOA comes from. So, trigonometry, it comes from the Greek language, and what it means is literally the measurement of triangles. For trigonometry to happen, you have to have a triangle, bottom line. Okay? And then the important thing to understand with trig is you can solve for two things. You can solve for a side length, you can solve for an angle. Trigonometry allows you to solve sides and angles in any type of triangle, whether it's right, obtuse, or acute. Doesn't matter which one. For this class, we're only going to stay with the right triangles. So that's kind of nice we stay consistent there. But in Algebra 2 and later classes, you actually will solve for obtuse and acute triangles using trigonometry. Okay? So measurement of triangles, that's what we're dealing with. Okay? We've got to get some really important terms to understand here. So this right here, a trigonometric ratio. We know what a ratio is. It's a comparison of two things. Well, in a triangle, we're comparing two side lengths. Okay, so you got to understand that a trigonometric ratio, that's just comparing two different sides in one triangle. We don't switch gears and compare triangles anymore. We're just in one. In a little while, we will actually use a comparison of the sides and the angle. So we will get there too. Comparing sides to angles. And how do we compare sides to angles? What do we know about that? They're proportional. So how do I know the hypotenuse is opposite the 90-degree angle? Because it's the largest angle. Exactly. So it forms the largest side. That's what we're going to compare. Okay, I told you to get calculators. You had to have three buttons: sin, cos, and tan. Well, this is where they come from now. Sine, cosine, and tangent. Those are our three trig functions. So, sin button goes with which function? Sine. Yep, this will be the sine. Cosine will go with what button? Cosine. For the cos. Tangent, tan. Memorize those. Sine, cosine, and tangent. The first part of trig, other than understanding like opposite and adjacent and hypotenuse, bottom line is a lot of memorizing. Because you have to know what sine is, you have to know what cosine is, and you have to know what tangent is. But that's why we give you a lovely acronym, SOHCAHTOA. So it's easy to remember. Okay? And we'll learn what that is in just a minute. Alright, so any questions so far of what trigonometry is? Making sense? Alright, a couple other important terms. Opposite, adjacent. We know what that means, right? Opposite means to be what? Across from. Yep. Adjacent means to be next to. We all know what the hypotenuse is, right? Perfect. Okay. Notice angles, capital letters. Sides, lowercase letters. That will always be true. Angles are always capital. Okay, side lengths are always lowercase. Okay, So if I go ahead and I stand at angle A, that's where I go. Angle C is my right angle. Angle A and B are my acute. So if I stand at angle A, what side am I not touching? What side am I opposite of? Little side A or CB. Yep, I can write it two different ways. So little a or BC. I'm going to still stand at A. And now I'm going to look at the adjacent side. What side is adjacent? Now be careful. We're saying B and we're saying C. What do I know C is though? C is the hypotenuse. So once I identify that, that's out of the question. So I actually can't use that as an adjacent side because that's specified to be something specific. Okay, so it is the hypotenuse, it's not an adjacent side. Or I can say it's AB. Alright, so going back to A, the adjacent side then is what? It's little b, or AC. Okay, now I switch gears, I go stand at B, because I can move around my triangle. Now I'm at B. What side am I not touching? Little b, or AC. And then the side that I am touching, little a, or BC, I'll just say. Now, the other thing to pay attention to, I will never go to my right angle and ask what's opposite it. That's a hypotenuse. And once we get going with sine, cosine, and tangent, the ratio I would set up, I'm never going to go to the right angle. Okay? So really, you're only going to use sine, cosine, and tangent at the two acute angles in the triangle. Never, ever the 90 degrees. Understand that? Okay. All right, so now let's figure out what SOHCAHTOA is all about. Okay, so looking at SOH, CAH, and TOA, what do you now know is in SOHCAHTOA? Sine, cosine, and tangent. Exactly. So the S, the C, and the T are our three trig functions. So now, what did I say a trig function represents? That first line. What? Someone's saying it. Side ratios. The side lengths put into a ratio. Okay? So, let's figure out what those ratios are. The O, the H, and the A. Draw these. So you have sine first. Okay, that's the SO part, the SOH. Okay, sine, the S. So sine of an angle A, when I stand at A, I just choose that one. That is the opposite leg, or the opposite side, over the hypotenuse. That's where the SO comes from, the SOH. Sine is opposite over hypotenuse. Now, you got to remember that it's opposite over hypotenuse because we'll later get inverses. So we actually use what's called cosecant, and that's actually hypotenuse over opposite. So we don't want to switch those. We want to remember that sine is opposite over hypotenuse. So SOHCAHTOA. So okay, so make sure you draw in that picture. These pictures will be very important today. So you can identify what's what. Because really, bottom line, that's what trig is all about. Identifying what sides do I have in comparison to the angles that I have. Okay. Alright, we got sine down? Alright. Cosine. That's the cut part of SOHCAHTOA. That's the CA. A represents the adjacent side. H is the hypotenuse always. So I'm going to change this here. Cosine of an angle is equal to the adjacent over the hypotenuse. There's your cut of SOHCAHTOA. So I'm standing at A. I go with the side that's adjacent to me over the hypotenuse. Not so scary so far, right? Because every time I ask what you know about trigonometry, guess what the first reaction is? It's hard. Not so bad yet, right? It's honestly, it's just a lot of memorizing at the beginning. Understanding what SOHCAHTOA is, what sine is, what cosine is, what tan. Okay? We have cosine down? Almost. Some people are still writing. All right. Tangent, that's the TOA. What's that going to be? Opposite leg over adjacent leg. Very good. So TOA, opposite over adjacent. Now again, remember, I don't have to be locked at angle A. I could move down to another angle here, but that'll change a little bit. But the thing to remember is whenever I have tangent of an angle, that's always the opposite side over the adjacent side. That never changes. Your placement might change, but that equation never ever changes. Okay, so I have a question. What do you notice? How many things and what are those things that have to go in to our trig equation? How many things do I actually have? I have 3 things. What are those 3 things that I have to have my trig function? Okay, yeah, I have to have those, some sort of ratio there. Dealing with my opposite, my adjacent, and my hypotenuse. So I have to have a ratio. What else do I have to have for this equation? I have to have an angle, and you have to have your trig function. You have to have sine, cosine, or tangent. So bottom line, trig functions, you have to have one of them, you have to have an angle, and you have to have a side ratio. Those last 2, the angle and the side ratio, those are the 2 things we're going to solve for. You're never going to solve for sine, cosine, or tangent, what it actually is. Does that make sense? Okay. You're going to have problems like this where it just says evaluate. Okay, what you're going to do is you're going to pay attention to what they give you, sine of A, cosine of A, or tangent of A, and you're going to go to that degree. You're going to stand there. So if I go to angle A, sine of angle A is opposite over hypotenuse, correct? Because that's the SO part of SOHCAHTOA. Opposite of A is my 5. Hypotenuse is 13. Adjacent is 12. I'm only at A. Okay? I could move, but I'm only choosing to be at A right now. Alright, so now if I ask you what is the sine side ratios of A? Well, what do? Yeah, I plug those numbers in. 5 over 13 and I'm done. That's it. Now, with these ones, problems like this, I will have you leave it as a fraction. I'll show you later when we'll get a decimal. Okay, so cosine, that's the cut. That's the adjacent over hypotenuse. So what is cosine of angle A? 12 over 13. And I'm done. I just evaluated the cosine of angle A to be 12 over 13. And I'm done. Tangent, that's the TOA. That's the opposite over adjacent. Evaluate tangent of angle A. 5 over 12 and you're done. Easy so far? Is anybody confused where we're getting numbers from? Perfect. So everybody understands what it means to be opposite and adjacent, and we all know what the hypotenuse is. Okay. Let's go to page 845 in your book, and let's look at that table real quick. Now, our trigonometric ratios, we usually leave it as a fraction. But what does it actually mean to have a fraction? What do you actually do with that? What operation? Division. Yep, you divide. So ultimately, my trig ratios could be written as a decimal. Okay? If you look at this table, the orange columns, those are your angles. Remember, we need three things for a trig function. Orange are our angles. There's our first thing. Sine, cosine, and tangent. There's our second thing, being one of the trig functions. The third is our side ratio. But notice they don't give you fractions. They give you decimals. So calculate 5 divided by 13 for me real quick. Give me 4 places. 0.1. Okay. Now, go to your table, and we are going to find what actual angle has a sine side ratio of 5/13, which is 0.3846. Okay? So go to your sine column and locate that. Some of you are looking at me funny. Why? It's not on there. So what is that telling us angle A is? Very good. It's between 22 and 23 degrees. Okay, we don't know the exact value. We just know it's somewhere in between there from the table. So, who wants to make this your new friend carrying it around? How many want to carry this book around? Okay, so Nick does. Nick can. Okay? Now, you have something that's 10 times lighter, and that's your calculator. Okay? So you have one option of looking in the book. Or you have this awesome friend, your calculator. Okay? We'll get to the calculator portion in a little bit. So hold off on your calculator for now. A lot of the times with your trig functions, you will leave them exact. When we say exact, it's a fraction and it's radicals, never decimals. Okay? What if I just told you to evaluate? Raise your hand if you know what to do. If I just literally say evaluate and there is nothing else that I say for this slide. I got 1, I got 2, maybe 3, maybe 4. Some of us, okay? Some of us see kind of what to do. What should I do first? Anthony? Absolutely mark up the sides. You have 45, which means you have a 45, 45, 90, which means the sides are congruent. These are x radical 2. So this is 3 radicals. First place to start. Very good. Now, it only tells you sine of 45, cosine of 45, tangent of 45. But you have 2. Does it matter which one I pick? Why not? They're both the same, and what do I know about an isosceles right triangle? They have the same sides, right? The angle crosses those opposite sides, they're the same. So, opposite over hypotenuse, what is it? Depending, and I don't care where you go. Either one you choose to be at, what's your opposite side? It's 3, and then your hypotenuse, no matter what, is 3 radical 2. Don't leave it like that. Radical 2 over radical 2, well, that's equal to 3 radical 2 over 3 times 2, which is 3 radical 2 over 6, which is radical 2 over 2. Okay, we moved quickly with that, but are we okay simplifying that? Now, without even doing any calculations, what's cosine going to be? Not opposite. Adjacent over hypotenuse. So what is it going to be? It's the same thing. It will be 3 over 3 radical 2, but isn't that what I just did for sine? So it's going to be the same thing. 45 degrees is really nice that way. I'll tell you right now, no matter what those side lengths are, this is what it reduces down to. No matter what. I could put 1,000 for those side lengths. It will reduce down to radical 2 over 2. Okay? Tangent, TOA. Well, that's easy. That's 3 over 3. That's 1. These, along with the 30 and the 60, you will get tired of because you see them all the time in trig. Okay? So it is worth your while, worth your time to kind of memorize. If I have 45s, I have radical 2 over 2, radical 2 over 2, and 1. But if you don't memorize that, SOHCAHTOA is where it's at. Okay? Questions on sine, cosine, and tangent for 45. When you have your special right triangles, I don't want a decimal. I want the exact, okay? Go to 30, 60, 90. What side is the 3? That's the x. X radical 3 and 2x. So this is 3 radical 3, and that is 2 times 3, so that's 6. Okay? I'm going to go and stand on 30. That's where I'm at. I'm going to start there. Sine, what's opposite from me? It's opposite 3. What's my hypotenuse? 6. Fraction, 1/2. Good, reduce. So that's opposite over hypotenuse. Cosine. Cos, so A over H. What side am I touching now? 3 radical 3 over hypotenuse 6. Simplify. Radical 3 over 2. TOA. Opposite. 3 over 3 radical 3. You're going to get a lot of 3's here. Okay? So simplify this. 3 radical 3 over 3 radical 9. 3's cancel off. Radical 3 over 3. So a lot of 3's there, but you know how to simplify. Anybody confused where we're getting these numbers? Scary so far? Yes. What's scary? Where are we? Just too many. It is a lot of numbers, yes. But bottom line, is it making sense? Okay, and I understand. SOHCAHTOA is brand new. That's going to take some memorizing. But when we're explaining it, is it making sense? Okay. I'm going to go stand on 60 now. What am I now not touching? 3 radical 3, that's on top. What is my hypotenuse? 6, what happened? It's the same as cosine of 30 degrees. That is not a coincidence. 60 degrees, what am I touching for cosine? 3, my hypotenuse. 6, what did that switch with? Sine of 30, that's not a coincidence either. No, it's not going to say that. What is my opposite side? 3 radical 3, what side am I touching? 3. So it's radical. Okay? These 3 will show up a lot. 45, 30, 60. So, again, if you don't memorize these, SOHCAHTOA is where it's at. SoCa will become your best friend. Yay, some of you are so excited. Named SoCa. All right, any questions before we throw a lot of stuff together? It'll be okay, I promise. Okay. Calculator time. You won't have to cry, I promise. All right, calculator. Now, we're going to mess with the calculator, but you got to take notes as well, okay? So, it says to evaluate each trig function. What 3 things do you have to have for a full trig function? A trig function, an angle, and a side ratio as a fraction or a decimal. Okay? What are you missing here? The ratio, the decimal. So anytime you see evaluate each trig function, you're missing the side ratio, so that means to solve for the ratio. I would definitely jot that down. Evaluate a trig function means to solve for the missing ratio. Now, you got to pay attention to your calculator. If you let a sibling borrow it or a friend in a higher math class borrow it, you got to make sure you're in the correct mode. You will always want to see D or DEG. You want to be in degrees. 9 times out of 10, if you just got it, you're fine. Okay, so we'll mess with that in a second if you're not getting the answers. Okay, let's evaluate sine of 25. Locate your sin button and press it. Type in 25, hit equals. Those are the 3 buttons that you need to press. What are we getting for sin or sine of 25? Give me 4 decimals. How many did not get that? Show me your calculator. You might have to go backwards. So hit 25, then hit sine. Okay. Anybody else have to go backwards?
Please excuse this interruption. There has been a change in the buses this evening.
All right, now let's do cosine. Hit cos. 30, hit equals. Give me 4 decimals.
8.660.
Okay, 0.8660. Everybody still okay there? You will leave it at, yeah, at least like 4. Yep. Is anybody getting a fraction? Find a button that has a double arrow. You hit that and it'll give you a double arrow. Some are right above the enter. Some are up top. Some, they're all places. Okay, do tangent. Tan 68 equals button. Reagan, what are we getting?
2.4750868.
Okay, 4. I said 4. 475 1. Round correctly. Now, tangent will be the only one that can be over 1. If you get a sine or a cosine that is over 1, your calculator is in the wrong mode. Okay? Good way to check. You'll learn why later on. Okay, now, always in math, we do it one way, and then we go the other way. All right, finding an angle. So using your calculator or the trig table, we have to find an angle. So here, that's what we're missing. So what's the decimal representing? The ratio. Okay, now, on your calculator, to do this, you have to find the inverse function, which is the tan to the -1. Okay? You're going to hit that, so some of you have to hit second tan, others have to with tan. Okay, so second tan, bring that up on your calculator. Type in 0.4877. Don't forget the decimal. Now, give me to 4 decimal places what your degree is. 25.99. Okay, 85. Now, I'm going to have you round to the nearest 10. But because it's 9 here, you round up to 26 degrees. Don't forget your degree symbol, because we're going to get a lot of numbers to work with. You got to have that degree. Okay? 6 minutes left. Okay, so inverse sine, sine's the -1 of 0.563. Again, give me the 4 decimal places. 72.999. Are we sure it's 0? Should be 1. Yep. When I have you round to the nearest tenth, if that's what happens, yeah, 73. But others, you might not. You'll have an actual tenth value. All right. Are we understanding how to plug it in? Any other questions before we mush it all together? Joey? You, I think, do you have to work backwards for the first part? You'll have to do that here. So you'll type in the decimal, then hit second. Sign or second. And that should work then. Is that working? Okay. We're going to put it all together now. Okay? So, first one. Set up the appropriate trig ratio and solve for x. What is x? It's a degree. X is a degree. You don't know it's 30. You don't know the degree. That's what we have to solve for, okay? So I'm going to put what I'm solving for. I only know the 90 degrees, but I don't have that other one, so I can subtract from 180. I have to use trig. What sides have I been given to solve for x? Hypotenuse and adjacent. A, H, what function? Cosine. Okay, how do I set up my equation now? I have to have 3 things. How do I set this up? I do have to use a 4 over 5. Yep, adjacent over hypotenuse. What goes first? Cos of my degree is equal to adjacent over hypotenuse since it's cosine. So 4 over 5. So you do have to know how to set these up. Trig function, then your angle is equal to side ratio. Okay? Angle. How do I plug it into the calculator? Okay, do the 4 divided by 5 if your calculator won't. And then what do I do? What's it called? If I have the -1, the inverse. The inverse. So you'll do cosine to the -1 of 4/5. Some of you are going to have to take 4 divided by 5, hit enter, then hit the inverse cosine. Others, you can plug it in as it is. Okay, give me to the nearest tenth of a degree. 9. Be careful of our rounding. Make sure you put the degree as well.
It's close.
How many are okay? Okay, do we see how we got cosine? Do we see why it's this angle and why it's the adjacent and the hypotenuse? And we now know if I'm solving for a degree, I deal with the inverse. Okay. Now let's go down here. All it says is set up an appropriate trig ratio and solve for the missing sides. Now we have two sides. I could use Pythagorean theorem, but it's going to be r squared plus s squared equals 4 squared, and I'm stuck. Right? Okay, I'm going to ignore this angle for now. For now. I could find it. So I'm going to go to 36. What variable do you want to solve for? Okay, I heard s. So I'm going to ignore r for right now. Okay? 36, what side to what side? What do I have now? What's s to 36? Opposite? Oh, hypotenuse. Okay, what's that? OH. So, that's sine. Alright, so I have sine of what? I've got to go trig function angle equals ratio. So sine of, what's my degree? 36. Is equal to ratio. S over 4. Okay. I have a variable in the ratio. What do I do? Whole numbers. What can I put them over? Put it over 1. Now what do I have? Two fractions that equal to each other called, don't move. A proportion. Cross multiply. Okay? I cross multiply and I get s to equal 4 times sine of 36. Now I plug that in. Now you have to be careful how your calculator does it. Okay? So let's type this in. 4 sine of 36. Give me to the tenths. 2.4. That is what you should get. Now, how do we get r then? How am I going to get r? If I have two side lengths. Pythagorean theorem. So if I solve for r, I'm going to have 4 squared is equal to 2.4